let's begin the next topic. Remember last time we learned the basics of limits, what they were, how to use a graph to find limits, left and right hand limits, how to use tables to find limits, and even the idea of infinite limits, where they increased or decreased without bounds. Now, none of the techniques we learned were ideal, right? Using a graph is nice, but it doesn't really prove anything, and we're not always going to be given the graph of a function. Using a table also doesn't prove anything. It can be a little time consuming, and we're not allowed to use devices on quizzes or exams. So there's that. So instead, let's look at some more robust techniques. First off, remember that the one thing that we did notice was that if you plugged in a, like if you're looking for the limit as x approaches a of f of x, and you plug in a into f of x, and you find f of a, and it gives you a number, well then, you're done. That's the answer, right? If it gives you a non-zero number over 0, well then, you know that you're dealing with an infinite limit. You take a look at the left-hand and right-hand limits. This limit's not going to exist, but in particular, you want to see, do the left-hand and right-hand limits even equal each other? Are they going in the same direction? If not, well then the limit doesn't exist, and it's infinite. Let's look at some basic stuff. For number 1, limit as x approaches 0 of x squared plus x plus 2. And actually, we'll switch to green. So, no tricks here. We're just going to plug in 0. Done. All right, that's it. That's all we do. So the next one shouldn't take too much longer. Right, we just have 1 minus 1 over 1 plus 2, and that's 0 over 3, which is 0. Note that 0 in the top is fine. It's 0 in the bottom that's always the problem. Okay. Now, number 3 is a little more problematic because if we try to plug in negative 2 straight up, well, maybe you can see we wind up with negative 2 over 0, and I'm putting that in parentheses, right, because that's not a number. That's not defined. So what we have to do is look at the left-hand and right-hand limits. So what I'm going to do, I'm going to write an LH here. And I'm going to say, I'm just going to say as x approaches negative 2 from the left, we have, and there's no real technique here. This is just numerical reasoning, right? I'm going to look at the numerator and the denominator. And I'm just going to look at their signs. I know the denominator is going to 0. And I know the numerator is going to 2. Negative 2. So the only question is, what is the sign of the numerator? What's the sign of the denominator? Are we going to negative or positive infinity? That's all we're looking for. So we have the numerator, x is approaching negative 2. And x squared minus 4... actually, so I shouldn't even say is x approaching negative. I could, but what's really important is just that x is less than 0, right? We're looking at this at like as the numerator of the function, right? Okay, so we have that, and we have that x squared minus 4. Now here's the question: is it greater than or less than 0? Well, if x is less than negative 2, then it's like negative 2.01 or something like that. X squared minus 4 is always a little greater than 0. And so for that reason, limit as, well, maybe I'll write it on the next line. So the limit as x approaches negative 2 from the left of this guy equals a negative over a positive, which is negative infinity. Again, we already know it's infinite. We already know that. The question is whether it's negative infinity or positive infinity. So let's look at the right-hand limit, right? Same thing. As x approaches negative 2 from the right, right, we have, well, again, x is still negative, right? Still approaching negative 2. And x squared minus 4, now be a little careful here, right? We're talking about negative 1.999 or so. Whatever it is, x squared minus 4 is always less than 0. right? So note that the sign switched. Just make that minus sign a little clearer there. That's a minus, not a times, right? Minus, okay. So what that means is that the limit as x approaches -2 from the right of x over x squared minus 4 equals a negative over a negative, so it's positive infinity. So the limit as x approaches -2 of our function, not only is it infinite, it doesn't even exist, right? Because the left and right hand limits don't even equal each other. So that's our answer. Just to like that. Like, that's our actual answer. So if I ever ask you this problem on an exam, I do want to see all of this, or quiz. I want to see all this work. Yeah, that's a little much. I want to see this work right here. You don't have to write as much. I really need just the answers. Right? If you're able to do that in your head, then great. But I do need to see the left and right hand limits. All right, so let's try some others, okay? If we try number 1, I guess we plug in 2. We're going to get, it looks like, 0 on the top, and that's kind of weird. It looks like we're getting 0 on the top and 0 on the bottom. Okay, don't really know what's going on there. Okay, let's go on to the next one. Plug in 3, you get 9, plus 6 is 15. Oh, okay, 0 on the top and 0 on the bottom. What's happening here? Okay, well, if it were a non-zero number over 0, we would do what we just did there. It's 0 over 0. So what's going on? Well, if we don't know what to do, if our technique is not working, then we have to go back to basics. Let's bust out Desmos again. All right, use a table, use a graph. Let's see what's happening. All right, so if we get open Desmos here, let's try the first one, right? We'll say we'll say f of x equals, lovely, x squared minus x minus 2 divided by x squared minus 4x plus 4. And then maybe we can delete a couple of parentheses here, just for aesthetic purposes. All right, so anyway, using that nice little table technique, I think what we do is we do that. No, I know, it wasn't that. How did we... Oh, no, it was the gear. That's right, and then you do a table. That's beautiful. 1.99, I'll just do 2.01, just like I have it here. 1.999, 2.001. Right, so it's pretty clear that we're getting some crazy numbers here. Right, so it's pretty clear that the left-hand limit is negatively infinite and the right-hand limit is positively infinite. Okay, so it looks like this limit is not. It's going to be infinite on the left and right, and it's not going to exist. Okay, I'll just screenshot that for later. All right, good to know. Right, and I think if you can tell, right, if we take a look at x equals 2, right? Again, we've got a vertical asymptote there, right? Okay, so no surprise there. Let's take a look at the other function, right? So let's call this g of... No, one sec. Call this g of x equals... Let's use x squared plus 2x minus 15 divided by x minus 3. Okay, we do that, that. Right, and so now again, let's do that nice little trick there. We do that. That's so cool. All right. So once again, the function's clearly not defined at 3, right? We'd be dividing by 0. We're never allowed to do that. But this is interesting, because here it looks like we are approaching 8. Okay. Not what I expected, but that's what's happening, okay? So it seems like 0 over 0 doesn't necessarily mean it's undefined, and it doesn't necessarily mean that we're approaching a certain number either, it looks like we need to just do a little bit more work. That's lovely, right? So I'll just do that, right? Let me just crop the other one as well, the same sort of way. There, and something like that, okay? Right, so it does look like, it does appear that this limit does not exist, but that this limit equals 8, right? And again, if we take a look at the graphs, maybe I can just get the graph in there, crop this one more time, just to kind of show it there. All right, we've got that graph right there. Well, we got that right there. And then that is 2. There's that vertical asymptote. Right, and then for the other one, right, oops, I didn't cancel out that one, but I'll still crop it, you know, it looks like, yeah, that picture doesn't look so good. Let's spend one more second getting rid of that. That, take a screenshot of that, much better. Whoop, no. Get in there, and get back in there, and then we've got that. Right, so really quickly, let's crop this guy, just to point out that we do have what appears to be an existent limit. Okay? Right here for that one, okay? And move it right down there, okay? All right, so anyway, take a second, see if you can figure out how you might solve this. Turns out what you need to do is you need to divide out by the common factor, or common factors. Could be more than one. Right, so let's see what I mean by that. What I mean is that if we take a look at this, is there any way to simplify the top? Well, I think there is, right? Instead of writing it like this, we could write it like this. X plus 1 times x minus 2, right? I just factored the top. This is where factoring comes into play. And similarly, instead of writing the bottom like this, we could write the bottom like this. Right? And now you can see, oh, well, look at that. The common factors cancel. Maybe I'll use red so it pops, right? They cancel. So really we're left with just this. And notice that now we have 3 over 0. And while, you know, that'll take a little bit of work to solve, right? I'll just do this very quickly. So I'll say the limit as x approaches 2 from the left of x plus 1 over x minus 2 is going to equal, well, let's say we're going to 3. If x is less than 2, then the bottom is less than 0. So we have negative infinity. If we did it the other way, then we're going to have a similar reasoning shows we have positive infinity. So the double-sided limit does not exist, and now we've really proven it. We've really shown it, right? We didn't just kind of illustrate it. We didn't just show that there is strong evidence for it. We showed it, right, by dividing by the common factor, okay? Similarly here, we can just do is we can say, okay, we have the limit as x approaches 3 of, and instead of writing it as x squared plus 2x minus 15, we can factor. Pause it. See if you can factor it. It's going to be x plus 5 times x minus 3 on the top and x minus 3 on the bottom. You can just keep the bottom the same, and you can see that we cancel out. And now what we have is just the limit as x approaches, well, as x approaches 3 of x plus 5, and that very clearly is just 8. Okay? So these are called indeterminate forms. When you have 0 over 0 like this, that's called an indeterminate form. We don't know what's happening. Actually, let me write that up here. The result 0 over 0 is an indeterminate form. And what it means is that you need to work a little harder to figure out your limit, right? You don't know the answer. It's indeterminate. Okay? Let's spend a little bit of time on the following limits. Right? So for this one, well, if you just write it out, you can, well, we already did this one actually, right? Or I guess I'll just write it the way we had before, right? X plus 1 times x minus 2 all over, and this one looks like x minus 3 times x minus 2. So those will cancel. And it looks like we're left with 3 over negative 1, which is negative 3. Okay? Right? And I guess I probably should have just plugged in first, but sure enough, if you do, you're going to get 0 over 0, right? So, right, for number 2, same sort of thing, but if you plug in x equals 3, well, you actually get, let's see, 3 squared minus 3 minus 2 all over 3 squared minus 15 plus 6. This winds up giving you, is that 4, I think, over 0? So this just boils down to it. You know this is an infinite limit or it's not going to exist, right? Limit as x approaches 3 from the left of this lovely thing right here. Now this is a little bit complicated to try to figure out what's going on. What helps is if you factor it, which we've already done above, and you know that this is the same as the limit of x plus 1 over x minus 3, right? Because, again, we already factored it, right? Anyway, you see that this is going to be, that's a positive over a negative. So it looks like we're going to get negative infinity. Limit as x approaches 3 from the right of x plus 1 over x minus 3 is going to be positive infinity. So we have that the double-sided limit as x approaches 3 of this, note that's the same as what we had before, I should say does not exist. Okay. Next up, number 3, right? Well, notice that we can write this as limit as x approaches negative 1 of x squared times x plus 1 over, x plus 1 times x plus 1. Right? So again, stuff cancels. Right? And thank goodness, right? Because if we tried to plug stuff in, right, we wound up getting negative 1 plus 1 equals 0 on the top. And we get 1 minus 2 plus 1 equals 0. So we get 0 over 0, right? So we needed to do this, right? And sure enough, when we do this, we wind up getting 1 over 0. So it's another infinite limit, I'll say. Try to finish this one. Okay? Number 4, this is one you just kind of have to know it or not know it. Like, it's totally fine if you don't see this one, because x cubed minus 64, it's a difference of 2 cubes. If you don't know how to factor that, then that's okay. Not too often. But just so you know, this is how you factor it. You can multiply that stuff together. Believe it or not, that's how it cancels out. It's kind of nice. Anyway, on the bottom, it looks like we've got x minus 4 times, I think that's x plus 3. Right? By the way, if factoring is not your jam, then maybe take a look at that calc readiness here, right? Go to my classes, courses, and then Math 201, summer calculus readiness. It's wonderful. Anyway, now when you plug in 4, you get 48 over 7, right? Not the nicest number, but it's a number. It exists, right? So just to show you, indeterminate forms can lead to existent limits or non-existent limits. I really don't know. Now, what on earth is going on with 5 and 6, right? We've got radicals. Maybe we'll get lucky and plug it in and we won't get 0 over 0, except of course we will. This is a little bit different. This is another indeterminate form. It's the same sort of thing, except instead of factoring, we first have to multiply by the conjugate, then factor. Okay? So let's take a look. We have the limit as x approaches 2 of, right, just copy this down over this. Now, you remember what the conjugate is? Conjugate is the conjugate of a minus b. Let me just write this over here. The conjugate of a minus b is a plus b. Okay? So we're going to multiply this by x plus 2 plus 2. Right? And maybe we'll multiply the top and the bottom by that, right? We can't change the value of the fraction, so whatever we do to the top, we have to do to the bottom. Vice versa, right? And this is going to give us the lovely answer of, well, maybe it's not the answer yet, but the nice thing is we're going to have a minus b times a plus b. Foil that out. See what you get. You wind up getting a squared minus b squared, which is pretty nice. Why is that nice? Well, number one, it's fewer terms, but in particular, we have a radical. There's no middle term, so we're not going to have a radical anymore. And when you square the radical, it completely goes away. We have x plus 2 minus 4. Now, be careful. Make sure to square the 2, right? And all of this now, the bottom is kind of a mess. Do not bother trying to simplify it. Please do not waste your time. Don't do it. It won't get you anything. However, it might be worth your time to simplify the top, right? Because we get x minus 2 over a nasty bottom. But, oh, look at that. I see an x plus 2 or an x minus 2 on the bottom. That worked out pretty nicely. Now, remember, be careful. We're dividing by x minus 2, so we're going to replace that with a 1, not a 0. Right? And so we wind up getting 1 over, and at this point, it's just square root of 2 plus 2, because I'm plugging it in, plus 2, and it's 1/4. Now, if you told me that this limit had a nice little answer of 1/4, I don't think I would have believed you, but that's what the math is telling us. That's how it works. Put it in a graph and you'll see. All right, similar sort of thing going on in number 6. I'm going to start this off for you, but I want you to try to finish it. Limit as x approaches negative 3 of the square root of x plus 12 minus 3 over x plus 3. But what are we going to multiply it by? Yep, it's square root of x plus 12 minus, plus 3 over itself. Alright, so I'll do one more step for you. This is going to equal the limit. Note that I keep writing the limit as x approaches, right? Until I plug in the value for x, I always keep writing the limit as x approaches negative 3, right? Now remember, make sure to square that 3 so it's minus 9. If you do minus 3, it's going to screw you up. Remember, this is going to be a mess. Do not simplify it. Do not waste your time. Okay? And then remember, we want to simplify the top so we can factor it. So I'm going to do one more step. Screw it. I'll just do it all for you. I'm such a nice guy. But pause the video. Try to finish it yourself. But I'll do the rest of it. Alright, and of course, cancels out, and we are left with 1 over square root of 9 plus 3, which is 1/6. Alright, again, not what I was expecting, but that's what we got.